Welcome. Let's start with a simple question. Have you ever talked to a chatbot, unlocked your phone using your face, or asked a digital assistant to play music or tell you the weather? If you have, then you've already used artificial intelligence, or AI. AI is not science fiction. It's not about robots taking over the world. At its core, AI is about teaching computers to perform tasks that normally require human intelligence, like understanding language, recognizing images, or learning from data. This video is designed for beginners. You don't need to be a programmer, you don't need to know data science, all you need is curiosity. AI is powerful because it helps people work faster, make better decisions, and solve complex problems. In healthcare, AI helps doctors detect diseases earlier. In retail, it helps manage stock and personalize recommendations. In education, it supports learning in new and exciting ways. To make these solutions possible, platforms like Microsoft Azure provide ready-to-use AI services. You don't need to build everything from scratch. You just need to understand what AI can do and when to use it. So let's explore the key AI concepts, starting with one of the most exciting areas. Generative AI. Generative AI is a type of AI that can create new content. This could be writing text, answering questions, creating images, generating code, summarizing long documents. There are large language models, which are very powerful in general, and small language models, which are faster, cheaper, and better for focused tasks. Imagine you walk into a huge library. This library has millions of books on every subject you can think of: science, history, medicine, technology, art, cooking, and even poetry. Now imagine there's a person in that library who has read almost everything and can answer questions on nearly any topic you ask. That's what a large language model is like. A large language model, often called an LLM, is trained on massive amounts of information. Because of this, it can hold conversations, explain complex ideas, write emails, summarize documents, translate languages, and help with many different tasks, all at the same time. You could ask it to explain climate change, help you prepare for a job interview, summarize a research paper, and then write a poem, and it would handle all of that surprisingly well. But there's a catch. Because this model is so large and powerful, it needs a lot of computing power to run. That makes it more expensive, and sometimes it gives more information than you actually need. Now let's leave the giant library and walk into a small, focused office. Inside this office is someone who hasn't read every book in the world, but they are excellent at one job. They know exactly how to book appointments, answer common questions, and guide people to the right place. This is what a small language model, or SLM, is like. A small language model is trained on a smaller, more focused set of information. Instead of knowing a little bit about everything, it knows a lot about one specific area. For example, a small language model might be trained only to answer customer service questions, help patients book hospital appointments, classify emails, respond to frequently asked questions. It won't write a poem or explain quantum physics, but for its specific task, it's fast, accurate, and much cheaper to run. Here's a simple, real-world example. Think about a hospital. A large language model is like a highly knowledgeable medical assistant who can explain medical terms, summarize research, help staff write reports, and answer a wide range of health-related questions. A small language model is like a front desk assistant who knows exactly how the hospital works, where to send patients, how to book appointments, and how to answer common queries. Let's quickly meet some large language models. GPT-4, powerful, conversational, and creative. Claude, thoughtful, safe, and great with long documents. Gemini, strong reasoning with text, images, and code. Llama, open, flexible, and widely used by developers. These models are like all-round experts. They can talk about almost anything. Now, small language models. Phi performs surprisingly well at logical tasks, step-by-step explanations, and educational use cases, even though it is small and efficient. BERT, specialized for fast text understanding. It's commonly used for tasks like sentiment analysis, text classification, and search. TinyBERT focuses on running efficiently on limited devices. It's ideal for mobile apps, edge devices, and environments where memory and processing power are limited. Albert optimized for understanding relationships in text with less memory. In short, large language models are general thinkers, small language models are task-focused doers, and choosing the right one makes all the difference. Generative AI works using language model. When you use generative AI, you interact with it using a prompt. A prompt is simply a natural language instruction, like summarize this document or explain AI in simple terms. Generative AI is commonly used for chatbots, translation, content creation, and explaining complex topics in simple language. Now let's talk about how AI sees the world. Computer vision. Computer vision allows AI systems to understand images and videos. Think about how humans look at a photo and instantly recognize objects. AI learns to do this by being trained on thousands, sometimes millions of images. When AI looks at an image, it can understand it in different levels of detail. The simplest way is image classification. Here, AI answers just one basic question. What is this an image of? For example, it might look at a photo and say, this is a cat, or this is a car. The next level is object detection. Now, the AI doesn't just recognize objects, it also shows where they are in the image. For example, in a street photo, it can point out the car, the person, and the traffic light by drawing boxes around them. The most advanced method is semantic segmentation. Here, AI goes into fine detail and identifies every pixel that belongs to an object. Instead of drawing a box around a car, it colors in the exact shape of the car, separating it clearly from the road, the sky, and everything else. So in simple terms, image classification tells what is in the image. Object detection tells what and where. Semantic segmentation shows exactly what pixels belong to what. Each step adds more detail, helping AI understand images more like humans do. Some modern AI models are multimodal, meaning they can understand images and text together. For example, they can look at a photo and describe what's happening in words. Computer vision is used in facial recognition, retail checkout systems, security monitoring, robotics, and self-driving vehicles. Next, let's listen to how AI hears and speaks. Speech AI. Speech AI allows people to interact with technology using their voice. There are two main capabilities. The first is speech recognition, where spoken words are converted into text. This is how voice assistants understand what you say. The second is speech synthesis, where written text is converted into spoken words. This is how AI talks back to you. Speech AI is used in voice assistants, call transcription, meeting recordings, language translation, and accessibility tools. Modern speech systems are getting better at understanding accents, ignoring background noise, and producing more natural, human-like voices. Now let's explore how AI understands written language. Natural language processing, or NLP. NLP helps AI make sense of text. Not all language tasks need generative AI. Sometimes simpler NLP models are faster, cheaper, and more reliable. Common NLP tasks include text classification, such as identifying whether feedback is positive or negative. Key phrase extraction, to find important terms. Entity recognition, to identify names of people, places, or organizations. Summarization, to shorten long text while keeping the main ideas. NLP is used to analyze customer feedback, review social media posts, process documents, and build simple chatbots that answer common questions. Another powerful use of AI is extracting information from unstructured data. Data and document intelligence. Businesses deal with huge volumes of documents, forms, invoices, scanned papers, audio recordings, and videos. AI helps extract useful information from these sources. A key technology here is optical character recognition, or OCR. OCR allows AI to read text from images and scan documents. OCR is often combined with other AI models to extract specific fields, like names, dates, or amounts. This is used for processing expense claims, digitizing old records, indexing documents for search, and identifying action points from meeting recordings. As powerful as AI is, it must be used responsibly. Responsible AI. Responsible AI means building and using AI in a way that is fair, safe, and trustworthy. Key principles include fairness, avoiding bias and discrimination; reliability and safety, working as expected; privacy and security, protecting personal data; inclusiveness, supporting users with different abilities; transparency, being open about how AI is used; accountability, ensuring humans remain responsible. For example, an AI system used for loan approvals should be fair and explainable. A facial recognition system should protect personal data. A chatbot should support accessibility features like captions. AI should support people, not replace responsibility. Now, let's test your understanding. What is the main purpose of generative AI? Generative AI is used to create new content such as text, images, code, or summaries. What is the difference between image classification and object detection? Image classification identifies what an image is about, while object detection identifies objects and their locations in an image. Which AI capability converts speech into text? Speech recognition converts speech into text. Name 2 real-world uses of natural language processing. Examples include sentiment analysis, document analysis, chatbots, and text summarization. What does OCR stand for, and where is it used? OCR stands for optical character recognition, and it is used to read text from images or scan documents. Why is responsible AI important? Responsible AI is important to ensure AI systems are fair, safe, secure, inclusive, and trustworthy. You've now explored the fundamental concepts of artificial intelligence and how they come to life using platforms like Microsoft Azure. Azure offers tools such as Azure OpenAI for generative AI, Azure AI Vision for image and video analysis, Azure AI Speech for voice recognition and synthesis, and Azure AI Language for understanding and analyzing text. Together, these services allow organizations to build intelligent solutions without needing to be AI experts. But Azure is not the only option. There are several other platforms that make AI accessible. AWS offers tools like Amazon Recognition for image and video analysis, Poly for text-to-speech, and Comprehend for language understanding. Google Cloud Platform, GCP, provides Vertex AI for building and deploying models, Vision AI for image analysis, and Natural Language AI for text analytics. Oracle Cloud Infrastructure, OCI, includes AI services integrated with enterprise systems, such as OCI AI Vision, Language, and Speech. And OpenAI provides powerful generative AI models that can create text, images, and code, either directly or through other cloud platforms. Together, these platforms give organizations the ability to build intelligent, scalable solutions without needing to be AI experts. Thank you for listening, and welcome to the world of AI.